When you do a statistical analysis, there are different types of data that you can collect. And so in this section, we're going to talk about some vocabulary for those different types of data. There are two main categories for the types of data, and those are qualitative and quantitative. And we're going to talk about both of those, and then we'll also talk about some different types of quantitative data. Qualitative data are data that fall into categories that are not numerical. So male versus female, your favorite color, what color your hair is, what kind of shoes you like, those kinds of things. There are two exceptions: social security numbers and zip codes, and other things like that, phone numbers. These are actually qualitative because when you look at a social security number, you're not looking at the number as an amount, you're looking at it as an identifier for a person. So that would make it fall under qualitative. Quantitative data are data that have numerical values, and so we'll be using these more in this class. Things like weights, heights, number of cars on the street, etc. And then when you do calculations on these, we have some different terminology depending on whether we're talking about a population or a sample. So if I talk about the mean weight for the group, then if that group is the entire population, then I'm going to call it a parameter. But if I'm talking about the mean weight of a sample, then that value is a statistic. So when you're talking about quantitative data, there are two types of quantitative data. One is discrete. Discrete data are values that are countable, which means they're usually whole numbers. So I've got some examples there on the screen. But then there are continuous values. Continuous values don't have gaps in between them, so they can be decimals out to any decimal place you would want. So I have some examples there. Amounts of liquids could be any decimal place worth of gallons. A weight, if you really wanted to be very precise, you could go out to many decimal places on a weight as well. Distance, weight, and height are very common continuous values. You do need to watch out for one major exception though, and that is money. Dollar amounts can be decimals, but they can only go out to 2 decimal places, which means there's still a gap between $1.25 and $1.26, because you can't have $1.25 and a half. So the way to think about this is that you're counting whole pennies. So since you can count the amount, this would actually be discrete. Another way that we can classify quantitative data values is by the level of measurement, which talks about what sorts of calculations are possible on the data that we've collected. The first level of measurement is nominal. These are things that are categorical or qualitative, so no mathematical calculation can be done on these. The second level is ordinal measurement. You still can't do any mathematical calculations on these, but you can at least put them in order, like letter grades. Now, don't think about GPA, just think about the letters themselves. You do know that they go in a particular order. A comes first, F is last, but you can't actually do any calculations on them because they're just letters. The last two levels of measurement are quantitative, and the third one is interval. With the interval level of measurement, you can put them in order and you can do calculations on them. They have numerical values, but there's no natural starting point. So you can, for example, with temperatures, these are an interval level of measurement because temperatures have negative values. There's no natural zero starting point because you can go both positive and negative. Years are another example because you can go negative, which would be the BC years. With these, you can subtract to figure out how far apart things are, but you can't say that 1 year is twice as many as another year. You can't say that 20 degrees is actually twice as hot as 10 degrees, but you can do some numerical calculations. The last level of measurement is ratio. These are also numerical values, but these are ones that there's actually some zero starting point. For example, with heights and weights, you can't go negative, so you really do have to start at zero and count up. And what that lets you do is talk about somebody actually being twice as tall as someone else. You can have ratios like that. Prices of textbooks, dollar amounts are another example. So the difference between interval and ratio is that with interval, you can figure out how far apart things are, but there's no starting point because you can go negative. So you cannot say with interval that something is twice as many. But with a ratio, you don't have negatives. You have a zero starting point, and so you can say that something is twice as large. And then just to summarize, I have a slide here where you can compare the different levels of measurement.